How about delta K over L? What is that going to be? Anybody know? How would we figure out delta K over L? Let's think about it. Any ideas? We need something we haven't talked about yet. We've talked about the rate of productivity growth, but we've left out an important dimension, which is what we call technical bias. What do we mean by technical bias? What do we mean by bias in technology growth? Think about it in terms of labor and capital. Here's L, here's K. Here's the Y equals 100 isoquant, right? That's the Y equals 100 isoquant. What is technical progress? What do we mean by, say this is L, K. That's our initial output. What do we mean by technical progress? What happens to the Y equals 100 isoquant when there's technical progress? Which way does it shift? In, right? I mean, that's kind of the always part you have to remember. Technical progress is shifting in. Less resources, right? Less production functions shifting out, but that means the isoquant shifting in. Now, what do we mean by technical bias? Well, the idea of technical bias is as this curve shifts in, is it twisting one way or the other? Technical bias in favor of labor would mean it's sort of shifting in like that. It's getting steeper, right? And the way to think about that, what that means, if it's getting steeper, this is biased toward labor. And then think about it three ways. And then I'll stop here and I'll pick up from here next time. One, at a fixed L over K, W over R is rising, right? That is, the curve's getting steeper, which corresponds to W over R going up. Two, at a fixed W over R, L over K is going up. Right? That means at a fixed rate, at a fixed slope, you're going to substitute toward labor, right? You're going to move over this way. And number three, TFP faster at higher L over K. Right? In fact, that's what's causing this isoquant to twist, right? That is, why is the isoquant twisting? Because we're pulling it in faster on this side than on that side. Because if we pulled it in at a kind of constant rate, if we pulled it in same percentage along every ray, then it would be neutral, right? We would just be using 20% less across the board. So all these things are really the same. They're all really telling you the same thing. We're twisting this isoquant this way as it comes in. Now you can think about, well, what's the effect of this going to be on labor share? Well, if L over K is fixed, W over R is going up, is going to raise labor share. If W over R is fixed, L over K going up also going to raise labor share. So all these things are going to be pushing up labor share if it's biased toward labor, and it's going to be pushing up capital share if it's biased toward capital. Okay? So that's one of the things that can also be important in this model. Do we have technological bias in favor of labor or technological bias in favor of capital? How do we measure technical bias? Well, one simple way of technical bias is just delta B equals delta W minus delta R minus 1 over sigma delta K minus delta L. Okay? That is, it's a residual again, right? We're measuring it now as a residual. This is the change in W over R, And this is what we predict based on K over L changing. Or you can write it delta B. This would be the price measure. If you want to measure it in quantity space, it would be delta L minus delta K minus sigma delta R minus delta W. Okay, because this would be the increase in the labor to capital ratio minus what you'd expect based on substitution, right? So it's the same, either one. So those are two measures. They're just in different units because one's in the quantity world and one's in the price world. But they're always going to, they're just differ by 1 over sigma, I think. Do I have it right? I think I did okay. Am I backwards? No, I'm okay. Because delta W got a positive sign here and delta R got a negative sign, which is what it has here. So it's got the same sign, just one's in. They differ by whether they're divided by, one's got the sigma, one's been divided by sigma versus the other. Cobb-Douglas are the same.
Just now you wrote the equation actually just recently. That is, this guy, the delta B is equal to 0, right? So why is the thing?
What do you mean delta B?
Delta L minus delta K equals 1 over sigma.
That's what you would expect if there is no technological bias. That's the equation you get for a given production function. For a fixed production function, that's true.
Oh, for fixed F, right?
For fixed F. This is a measure of how F is twisting. Just like TFP is a measure of how F is increasing or decreasing, this is a measure of how the isoquant's twisting.
Oh, so suppose that there's a times A. If the technological progress, is outside the function F, then
This will be 0.
This is 0.
Yep, exactly. All right. So we'll come back to this because this is going to then allow us to say what is the short and long run impact of technological progress? How does it vary with, the technical bias and the degree of substitution and all that stuff? Okay, that's where we want to go. So going back to our ideas on technological progress, we got a couple of equations that I think are quite useful. And so for now, I'm going to measure everything in real terms. So I'm going to get rid of the P terms. And when I talk about delta W, that's going to be the real way. So it's really delta W minus delta P. And delta R is going to be delta R minus delta P. And you don't want to carry all those things around. So just everything's in real terms. So expressed in real terms, the basic broken down equation on the price side of things basically says that the increase in total factor productivity is going to translate into an increase in the payments to factors on a per unit basis. You can think about this as almost like a unit cost relationship, right? It says if unit cost is going to go down by 10%, then that's going to allow us to, in real terms, pay 10% more to each of the factors. And that could be more than 10% more to labor and less than 10% more to capital, but it has to work out kind of one for one. Everybody understand the idea? We're getting more productive, so that allows input prices to rise relative to output prices. Right? Think of it this way. Start with an equation like price equals marginal cost, right? Well, marginal cost is equal to factor price divided by marginal productivity, right? That's just like, price times marginal product equals wage rate, right? This is generalized to more than one input. So price equals marginal cost is price equals factor price divided by productivity. So if this goes up 10%, that allows factor prices to rise 10% for a given level of price. Okay? So that's basically the idea, and that gives us this as sort of a simple equation. And it says, look, if productivity is rising through time, that's going to allow us to pay more to the inputs. Now, that doesn't tell us which inputs are going to get more. It doesn't tell us whether that extra return is going to go to workers in terms of higher wages per hour, or is it going to go to capital in terms of a higher return on capital. In order to say that, we have to take a stance on how things change. So you might think about a short-run world. In the short-run world, I'm going to think of L and A are fixed. Because that's what I'm going to think of as the short run. That is, in a very short run, labor and capital are fixed. And any increase in productivity will just be more output from fixed inputs. We don't have any more labor than we had the day before. We don't have any more capital than we had the day before. So the increase in output is just going to be equal to the increase in productivity. Now you might say, well, that's an unrealistic model of labor because really, even though maybe we can't increase the capital stock in the short run, people can work more. We have a labor supply response. And if you're interested in business cycle time frequencies, I agree, that would be important. I want to bring that in. But that's just going to complicate my world a little bit from where I am. So what we think about is on the other side of the model, we can think about, and this is where we ended up last time, delta W minus delta R, which is change in the relative price of labor, is going to be equal to 1 over sigma times delta K minus delta L. Right? So remember, I got that same trick we always do with the elasticity of substitution. I got W relative to R on the left, and I have K relative to L on the right. So this will be a positive effect now, right? Now usually you think about it as the elasticity of substitution, which is how the quantities respond to prices. If I'm looking at prices relative to quantities, that's why I'm getting a 1 over sigma in this relationship. People understand that? That's why there's a 1 over sigma plus delta B, which is our technological bias that we ended the lecture with last time, which tells us how the technology is shifting capital relative to labor, how that isoquant is shifting in, and whether it's biased toward labor or biased toward capital. Now, often you'll hear people talk about factor augmenting technological progress. Factor augmenting progress and technical bias are not the same concept. Okay? Factor augmenting technical progress, people model something like this. They'll say y equals f of, A of t times L, B of t times K. And they'll think of A as labor augmenting technical progress and B as capital augmenting technological progress. Turns out they're not really, that doesn't tell you even the direction of technological bias. For example, in the Cobb-Douglas case, A and B really amount to the same thing. That is A, for Cobb-Douglas, this would be like A of t L to the alpha, B of t A to the beta, or 1 minus alpha, which would be equal to A to the alpha, B to the t to the 1 minus alpha, times L to the alpha, K to the 1 minus alpha. So these two terms would just combine together. They would act exactly the same way. And in general, depending on the elasticity of substitution, will determine which way these things bias. So if the elasticity of substitution is bigger than 1, then A will be biased toward labor. If the elasticity of substitution is less than 1, B would be biased toward labor. Just flips which way it goes. When the elasticity of substitution is 1, they're both neutral, right? This is how the world works. And I like to think about technological bias because that kind of is a much simpler way to look at the world. Now, one thing that's a little different between measuring technological bias and measuring technological progress. Remember, we can measure technical progress as delta TFP equals delta Y minus SL delta L plus SK delta K, right? right? That was our measure of technological progress. The most common measure was the measure on the quantity side as the growth in output minus the growth in inputs. Okay? Now, in order to measure the rate of technological progress, I don't need to know much about the production function other than share. It's kind of like when we wanted to measure whether people were better off or worse off, all we needed to know was the prices, right? That's really all. It's exactly equivalent to where we started in lecture 1, where we could measure whether the consumer was better off or worse off just by looking at changes in quantities at fixed prices, right? We could approximate the difference curve by the budget line. Here we're approximating the production function by the tangent, basically. We're approximating the production function. We're assuming each input is being paid its marginal product. For measuring technological progress, it's a little trickier because you have to estimate this parameter sigma. If you don't know what sigma is, you can't get a direct estimate of the level of technological bias. Often you can sign the direction of technological bias, right? Give you an example. Let's say that this is positive, okay, and this is negative. Well, in that case, you would know for sure that delta B would have to be a negative number, right? Because what you're seeing is K is going up relative to L, but W is going down relative to R. That can't happen unless there was technological bias. We know sigma is a positive number, right? So you can often sign, and that's just like when I see, in fact, it's exactly analogous. When I see this point and this point, what can I conclude? I can conclude demand must have shifted, right? I can't be moving along the demand curve if prices and quantities are going in the same direction. That's the same thing that's happening here. If this is positive, that means capital is going up relative to labor, and the price of capital is going up relative to the price of labor, which means the demand curve has to be shifting, which is what tells us there has to be a bias, right? It's the usual thing. You can't identify the level of the demand shift to the supply shift, but you can often identify the direction because of these inequality constraints. You know that demand will go down. In this case, you know sigma is positive. People understand that? So identifying technical bias requires an estimate of the elasticity of substitution. Because you have to net out of the factor price change, or equivalently the factor quantity change, what would happen because of substitution. Okay. But since you can sign the direction of substitution, namely if W is going up relative to R, you know that if he's substituting away from labor, or if R is going up relative to W, you know that he's substituting away from capital. That allows you to sometimes determine the sign of delta B, or at least put bounds on delta B more generally. Any questions that people have about that? Okay. So let's go back to where we were. So our equations for the short run. For the short run, we have, if we're holding L and K fixed, so the short run, this equation will become delta W minus delta R. This equals delta B. And our other equation is delta TFB equals SL delta W plus SK delta R. Well, this would imply delta R equals delta W minus delta B. Okay? So then delta TFB would be equal to SL delta W plus SK delta W minus delta B. Okay? You guys did that right. Which implies delta TFB equals delta W minus SK delta B, which implies delta W equals delta TFB plus SK delta B. And of course, the way we've defined delta B is biased in favor of labor. So if the technological progress is biased in favor of labor, that's going to be a further force increasing the real wage in the short run, right? Because TFP is kind of raising all factor prices on average, and the direction of bias is favoring labor relative to capital, so that'll actually cause the short run effect of the wage rate to be greater than it would be if the technological progress was factor neutral. Okay. Now, if we go through a period where the technological bias is actually the other way around, that is where technological bias is biased against labor, then that will be a force putting a drag on the increase in the real wage rate. Because for a given level of TFP growth, the bias is going to be favoring capital relative to labor. Okay? Now, what about capital share? What about labor share? What's delta SL? Or let me do it the other way. What's delta SL divided by SN? That's an easier one to do. What's the rate of change of the relative share of labor and capital? How would you get that? Anybody see how we can do that from what's on the board? This is something people focus on a lot, right? Is labor gaining, well, right? People talk about this going on. What's been happening in recent years?
Labor's been losing.
Labor share has been falling, which means labor share relative to capital share are going to be going down, because if labor share falling, capital share is rising, and so both of those effects are pushing this, right? That is a relative change. What would that be equal to? Well, isn't that just equal to delta W plus delta L minus delta K plus delta R? Everybody agree with that? That is, it's just changed. This is how much more labor is getting. This is how much more capital is getting. And therefore, that difference would be the change in the relative shares. By definition, right? That is the relative shares, right? Because SL over SK is just LW divided by RK. Just take total percentage change in that ratio, it's going to be exactly that formula. So what would that be in the short run? What would that be in the short run? In the short run, if these two are 0, okay, then that would be telling us that it would be delta W plus, well, it would be delta L 0. It would be just delta W minus delta R, which according to that formula there would be exactly given by that formula, it would just be delta B. Right? So in the short run, which is L and K fixed, this would imply delta SL over SK equals delta W over R equals delta B. All right, so that would be a measure of technological bias in that way, because there would be no substitution between labor and capital in that short run. Okay? If we're holding L and K. So you might think that that would be one force that would drive. Okay? That is holding those fixed. What about over the longer term? What would it be equal to over the longer term? Well, it would be delta W minus delta R plus delta L minus delta K, right? So it would be equal to, so delta W minus delta R plus delta L minus delta K would be equal to, according to my formula here more generally, 1 over sigma. Now what do I need? Well, I got a delta L, delta K on that side. So I think it's 1 over sigma minus 1 times delta K minus delta L plus delta B. So if we saw an economy, now the traditional view of long-run growth from Maxwell, what was the traditional fact people cited about long-run growth? Anybody remember? So, right? SL was constant. So what came out of the neoclassical growth model is delta R equals 0, right? Delta K. Here, delta K equals delta Y. Are you right? So what's the view of the world? And delta W was equal to delta TFP over SL, right? Those are kind of the facts that we would traditionally use. But what if we saw an economy where capital was, where labor share was falling? This is delta SL over SL. What would you think? What would be the two explanations you have for des L over SK fall? What would be the two explanations you have? Well, if sigma's 1, then there's only one explanation, right? Because if sigma's 1, then K over L doesn't really affect the factor ratio, I mean the shares, and therefore it's all about bias, right? That is the only thing driving increase in capital share or labor share over time would be all coming from technological bias. Well, what about if sigma's not equal to 1? What would happen if sigma were bigger than 1? What happens when sigma is bigger than 1? What if I had the neoclassical growth model facts? That is, the long run return to capital was constant, but labor share wasn't constant. Labor share was changing. And sigma were bigger than 1. What would the world look like? Let's assume, let's get out of the standard neoclassical growth model. But let's maintain the elastic supply of capital assumption. So I'm going to assume that I'm going to maintain delta R equals 0. That is, long run, over the long haul, return to capital isn't changing. Yeah.
What's the sense in which we assume that in the long run?
Well, remember our neoclassical growth model, right? What did our neoclassical growth model say? It said that the supply of capital was very elastic in the long run. That is, it didn't matter, right? That is, we got, because the rate of time preference was, if it wasn't varying with income, we had a very elastic supply of capital in the long run. We got 10 times as rich, we were 10 times as productive, right? Think about comparing two stagnant economies. One here with, GDP per capita down here, and then we're going to go up to this economy here with a much higher GDP per capita. We're going to compare those two equilibriums. Right. Now, in the neoclassical growth model world, what do these two worlds look like? What they look like is, let's say y over L equals 1, y over L equals 10. Right? So we've gotten 10 times as rich over this period of time. Take the standard neoclassical growth model with labor augmenting progress or any kind of progress in Cobb Douglas. You can take your choice, whichever one you want. What would the world look like here? So y over L equals 1. Let's say L equals 1, K equals 1. Everything's 1. Just normalize everything to 1 and stuff. R, W equals 1. Uh-oh. Oh, okay. And R equals 1. Right? I think that works. Right? That does work. Everything's 1 when I start. Everybody realizes that's just a choice of units, right? I'm just measuring everything where I take the initial units and I call them all 1. I think that works. Yeah. There's that. Or maybe it doesn't work. No, okay, we're paying too much, right? So I need L equals alpha, K equals 10. Because then LW plus RK equals 1. Okay, so that's my KC okay. Yeah, I'm okay, right? Yeah, so that's going to be my initial condition. what does the neoclassical growth model say the world would look like when y over L is now equal to that? What would they be? What would it be? Yeah.
K goes up by
W, call this period 0. I'm not even sure my units are right now. I'm not talking about. Call this period 0. W1 equals 10 times W0. R1 equals R0. Y1 equals 10 times Y0. R1 equals, I did R1, K1 equals 10, K0, L1 equals L1. That's a simple world. That over a period of time, we got 10 times as productive. Labor share stays constant. Why? Because the wage per unit labor goes up 10 times, while the quantity of labor stays fixed. On the other hand, on the capital side, the return per unit capital stays fixed, but we have 10 times as much capital. That's the classic neoclassical growth model of the world. So Y over L is staying constant, labor share is constant, because the price of labor is growing as fast as the quantity of capital. Okay. How would that world look if I had the world that I just described over here, where I don't have a constant, I don't have labor share being constant between the two periods? Okay. Think about what it would look like. What would the world look like? Well, we would still have to have what? We would still have to have delta R equals 0 because we got this long run perfectly elastic supply of capital. Right? The way to think about it is this. We had this huge increase in productivity that raised the return to both capital and labor. We then have more investment in capital, and we keep investing in capital until the return to capital gets back down to its long run level, and then we're going to maintain that capital size. That's where our new steady state is going to be. So we're going to maintain delta R equals 0. Now let's say sigma is bigger than 1. What's going to have to happen? What's going to happen after if sigma is bigger than 1? What's going to happen? What's going to happen? Anybody? What's going to have to happen if sigma is bigger than 1? We'll see how to do this. We'll see where we're headed. Well, think about what the long run says. What do our equations say in the long run? Long run. Remember, we have SL delta W plus SK delta R equals delta TFT. Everybody agrees with that, right? What if we just say it would have to be true in the long run? That would have to be equal to 0, right? Because the neoclassical growth model says we're going to have very elastic supply of capital. So capital is going to end up back to the same old return. So immediately we know delta W equals delta TFT over S. Right? That we're going to know that. So we've already determined the price side. So the growth in W, the growth rate in W, has to be equal to the growth in TFP divided by the share of labor. Okay. Now you might say, well, which share is it if the share of labor is changing? It's going to be some kind of average share over that whole period of time. Things will happen. True? All right. What else? What's going to have to be equal to true? What's going to happen to delta K over L? In order to get delta R equal to 0, what are we going to need to do? Well, we're going to have K go up enough to basically get a delta R equal to 0 when delta W is equal to delta PFP divided by SL.
See what's going on?
So what's going to happen is, the greater the elasticity of substitution between labor and capital is, and the greater the bias in technology is toward capital, the more we're going to have to increase the capital stock. Because we're going to have to increase the capital stock enough to get productivity down. Let me show you with a graph. Maybe that's the easier way. Think of it this way. Put K over L here. Put Y over L here. In a curve that looks like that, right? So this is the value marginal product of capital. Yeah. So that's the value marginal product of capital, schedule of capital. Oh, no, we put R. That's the value marginal product schedule of capital. Now, at a given level of K over L, this area is Y over L, I'm sorry. Right, that's Y over L. Right, because that's the total amount of output being produced by per worker, right? This is the marginal product schedule of capital. The area under that demand curve gives me K over L, I mean Y over L. So now what happens in the short run? In the short run, this curve shifts up, and we go up to here. And depending on the bias, determines how much of this is paid to capital versus how much of it goes to labor. Because capital is going to get the increase in the height of this curve as its value marginal product. And labor, right? So this goes to K, and this goes to L, right? L gets the surplus above the line, and K gets paid its marginal product. Okay? So you understand that? Now what happens in the long run? Well, in the long run, we move out to here. So L is going to get all the productivity growth, plus whatever we gain by increasing capital. That's basically the picture that we have. So that's the picture that will generate the long run problem. Now, when technology is biased in favor of capital, or technology, or the elasticity of substitution is bigger than 1, then labor share is actually going to fall because capital is going to go up so much. They're going to collect more. But the key is that increasing capital is actually giving more and more to labor over time. That's the important side of it. Do you understand how that works? Just look at this formula. There's delta W minus delta R. And substitute in delta R, delta TFT equals SL delta W plus SK delta R. So we can substitute in from this equation here. Well, we can do it either way. Solve this equation, delta R, I'm sorry I'm doing this in such a number way. Delta W minus 1 over sigma, delta K minus delta L, minus delta B. Okay? Everybody agree with that equation? Just solve this over to the other side. So I got delta W minus 1 over sigma, this minus delta B. Add in here, delta TFP equals SL delta W plus SK delta R, I'm sorry, delta W minus 4 over sigma, delta K minus delta L. W. So delta W equals delta TFP plus 1 over sigma delta K minus delta L plus delta. And that's probably the formula we should start. So that says the growth in the real wage is the growth in TFP plus some effect of capital deepening plus technological bias.
Where did the share of capital go with the, everything?
Oh, yeah,
except for-
that's sorry, we got a SK here. That's our capital deepening. Let me rewrite that. Just like the capital deepening formula we had last time, delta W equals delta TFP plus SK delta K minus delta L plus delta P. All right. So this is the growth in the real wage rate that we're going to see in the economy. This is the growth in TFP. And this is the growth of capital deepening that we had from our earlier formula. And then this is technological bias. Bias in favor of capital. Now, with new forms of technology coming out, our favoring capital over labor. And at the same time, capital substitutes more than one for labor. Okay? So now think about what this equation is going to have to say. Right? Well, what's going to have to happen in the long run? What's going to have to happen? Well, in other words, I got to drive delta R down back to 0, and I got to increase delta W. Right? That's what happens. If we go back to this equation. What happens is you have productivity growth. That would tend to raise the return of both factors. If it's biased toward capital, it's going to raise this one more than that. That's really all that's going on. Now, but in the long run, as long as we have elastic supply of capital, this has to come back down to 0, and this has to go up to basically delta TFP over SL. Right? That's what's going to have to happen. Now, but if sigma is bigger than 1, in order to cause that shift in factor prices, you're going to need more capital, right? Because the capital doesn't do as much to shift the returns between the factors. And if there was a bias in favor of capital to begin with, you got even further to go. So what's going to happen is you're going to get this big contrast between the short-run impact of an improvement in technology and the long run. That is, the impact, the difference between the short-run impact of this technological progress and the long-run impact of this kind of technological progress is going to be great. Because in the short run, it's going to tend to raise the return to both factors, and if it's biased in favor of capital, it's going to raise it more for capital than for labor. But in the long run, we're going to have to drive the return to capital back down. In order to do that, we got to increase capital even more than if it wasn't biased. And secondly, if sigma is bigger than 1, we got to increase capital even more. Right? And that's going to cause a lot of capital deepening. But if you have a lot of capital deepening and elasticity of substitution is bigger than 1, what's going to happen to shares?
They're going to be biased towards capital.
They're going to get even worse in favor of capital. So we have this technological bias that would raise capital share in the short run. The response of capital investments is going to raise capital share even more. But is that bad for workers? The answer is no, it's actually good for workers, right? Because that very process that's driving up capital share is the same process that's driving up delta W and down delta R, right? That is, so the same force that's causing capital share to go up even further in the long run is actually good for workers relative to capital, because it's shifting relative prices in that direction. But I did want to address this whole issue of what happens in a world where we get out of the neoclassical, the standard neoclassical assumption. right? I'm gonna maintain the elastic supply of capital, but I'm gonna get away from the assumptions that generate a constant share for capital and constant share for labor. In particular, I'm gonna skew things in a direction that makes capital share grow. I'm gonna have delta V be negative, so technological progress is biased against labor. That's gonna make capital share grow, right? And secondly, I'm gonna make the elasticity of substitution between capital and labor bigger than 1, which is going to tend to push us toward a growing capital relative to labor in the long run. And the key point, though, is the effect of capital deepening, which is even stronger in that case, right? The capital deepening effect is now bigger than it was in the standard model, still goes the same way. It still favors labor. It's still the process by which the benefits at the end of the day be competed back to labor, but it actually has the end result that capital share grows even more than it would otherwise. It's a very different view of the world, I think. It's a very different view of the world because it sort of says, oh yeah, what will happen if we allow the investment response that would naturally happen from an increase in the return of capital? The answer is capital share will go up even more. Like having capital share go up even more isn't necessarily a bad thing from the point of view of workers. They'd be getting a smaller share, but they'd be getting more in total.
Right, so why should we care about capital share? We only, at the end of the day, I think we only care about the weight, right? We only care
You're
about.
my vote, man. That's the vote I'm sailing on. You don't have to vote with me. Other people seem to really care. Now, you might say, well, capital share can matter for something. But again, the thing you always have to remember when you look at a share, it's LW or relative share. Think of it that way. It's LW over RK. And if you tell me capital is getting more without telling me how, I don't know what to make of it. If they're getting more because R is going up, well, I know more growth in R has to mean less growth in W holding technology fixed. There's just no two ways about it, right? Holding the growth in technology fixed, we got this teeter-totter between R and W. On the other hand, growth in K generally is going to be a good thing for labor, right? We're going to, in terms of my picture, we're going to move from here to here. Labor's going to get all the rest of this, right? I mean, that's what's going to happen as K grows. Here's the short one, right? K over L is fixed in the short one. Here's our old marginal product schedule of capital, right? And here's R. That's our initiative. If you had technological progress that was really biased toward labor capital, what would it look like? Well, it might look like this. That would be technological progress that would be really biased toward capital. But you see why? Because when people look what would happen in the short run. In the short run, labor used to get this, right? That's what workers collected, right? Because think of it this way, this is the amount of capital that we had per worker, A over L. That's the amount of capital we had per worker to begin with. That's what capital was earning. So if capital earned the rectangle, total product is the area under the curve. So labor must be getting the triangle. So what would happen to the income of labor in this world? There's technical progress because the area under the curve is up. But actually, workers are worse off than they were. Workers are worse off because this triangle here is smaller than that triangle. So we had extremely biased technological progress in this case. Technology improved, but it improved in such a way, it was so biased toward capital. This is kind of, I think, the example you had in mind before, which is workers, there's less demand for workers than there used to be. Given the amount of workers, they're going to get paid less rather than more. Right? But now look what's going to happen between the short run and the long run. Right? Between the short run and the long run, workers are going to pick up all of that, so they get back all the initial improvement, plus they're gonna get all that. Right? Now what would happen in a world in which technology was very biased for labor? Well, let's take it, not even as extreme case as that. Let's assume it was very biased for labor and it was like that. Now what would happen? In the short run, workers would get all the improvement, right? They would get all the improvement, but there would be no capital deepening response. The total increase for labor for a given level of TFP would actually be smaller than it would be here. They'd actually get more here than here, because here they only get the TFP growth that happened initially. Here they also pick up this additional triangle from capital deepening. Malthus had the same theory, right? Malthus's model is the same model we have on the board. Malthus has a model, you know, his equations basically are delta TFP equals SL delta W plus SK delta R. Right? And he's got, you know, so that's his view of the world, and delta W minus delta R equals 1 over sigma delta K minus delta L plus delta V. That's Malthus's theory. Except for Malthus's theory, he had a very different theory of supply. Malthus's theory of supply was delta W equals 0. His theory of the world was, if the real wage rate went up, people would just have more kids, and they would just keep having more kids until the return of labor went back down to where it started. That was his theory of the world. You can see it's the same model. It's no different. It's the neoclassical growth model with the role of labor and capital just flipped. His view of the world was, if productivity improved, we became better at growing food, then that would make people richer. And when people got richer, they'd have more kids, they'd live longer, population would grow, and we just have more and more people until we got back to be starving again. That's what would stop us from the increasing health relative to cash. Because in his world, K was very inelastically supplied, and L was very elastically supplied. The exact opposite of the neoclassical growth model. Which, for his model, kind of makes sense. Because in his model, what was K? K was land. And the second part was that fertility, that is population, had a very positive response to income. That if people got richer, they'd have more kids, and population would grow. Since K was fixed and L would grow in response to productivity, he said, well, we'll always be poor. Because however productive we get, we'll have enough people to make us poor again. Okay? Neoclassical growth model says, no, that's not how it works. In the neoclassical growth model, population isn't very responsive to the wage rate, and the limit is unresponsive to the wage rate. But importantly, capital is perfectly elastically supplied in the long run. So if we become richer, if you double the return to capital and double the return to labor, then you can't sustain that high return to capital. People are going to invest in capital, they're greedy, they want to make money, they're going to keep investing in capital and keep increasing the capital stock so the return to capital comes back to where it's from. Exactly the Malthusian model with the role of capital and labor reversed. Now you might say, well, why was Malthus so stupid? Well, he wasn't so stupid. I mean, that model has worked for 1,000 years or something. I mean, he had a pretty good empirical database to draw on. That he felt like, you know, we got more productive, but we just always had more people whenever we got more productive. What really changed was, one, capital became a different kind of capital, a capital that we could invest in. And number two, people changed. And they didn't just have more kids. Now, we're going to turn it in a minute to say, well, that doesn't mean they didn't invest more. That when the return of people went up, that they didn't have more investment in people. They just didn't have more investment in numbers of people. They had more investment in the quality of people. And when we talk about income, we measure it per person, not per quality adjusted person, right? So it's a very different notion of income. That's gonna get us into the notion of human capital. And that's where I'm gonna go next, is to talk about human capital and bring human capital into the growth model. Where we're gonna go next is to say, well, there's a key part of my story that's missing. The story I've told so far is all about physical capital and human capital. Physical capital and labor. What's been left out of my story is human capital. And I think we talked about this last time. If you look at patterns of long-run growth, one of the things you see is that not only have we had more physical capital per capita, we've had more human capital per capita. And I want to talk about it. And so we need to bring human capital into the equation. So now we want to think about three inputs. Okay. The three inputs I want to have are LH, which is high skilled labor. LL, which is low skilled labor. And K is physical capital. Of course, now there are three prices. There's WH, WL, and R. So now there are three prices that we have to think about. We have to think about high skilled labor, low skilled labor, and the return, the quantities of each, and the return to high and low skilled labor, and the return to capital. And the basic idea I want to think about is I want to think about the process of long run growth. And long run growth in my model is going to have the following three ingredients. I think we put these on the board before. Technology, call that TFD. I'm going to have capital deepening. K over L going up. So this is some composite of LH and LL, right? That's some increase more capital per worker, and human capital deepening. Which is LH over LL is right. Okay. So those are kind of the way I want to look at the world. And I think if you look at the facts line up very well with it. We have rising productivity over time. We have more physical capital per person over time, and more human capital per person over time. And how are these things all tied together? And again, just like we're going to need to do here, we needed to get sigma from some external evidence, we would need the same thing here. But I want to bring in a couple of points. One, technology bias toward LH relative to LL. I want to think about technical bias that's raising the demand for high skilled labor relative to low skilled labor. So that's one thing that's going on. And K is a substitute for LL and it's a complement for LH. So those are kind of the parameters I want to think about in my model. When I think about as capital grows, it's going to raise the relative demand for high skilled labor and lower the relative demand for low skilled labor. Okay. All right, so K over L goes up, for LH up relative to LL. And technology has that same effect. So both of these forces are pushing up the return to high skilled labor relative to low skilled labor. I wanted to make a table, and I wanted to think about growth. So I got technology, K over L, LH over LL, all those things going on. It's pretty clear that all these are making Y over L go up, right? I want to look at like output per person or output per man hour. Some measure of productivity. Productivity is growing for all these reasons, right? Why are we more productive than we were in the past? We got better technology. Each worker has more physical capital, and workers have more human capital. Let's go, all three of those add together to raise output per work. Right? Everybody understands? Better technology to work with, more capital to work with, and you got more human capital, you're going to be able to produce more output per work. No question about it. Yeah.
Is LH a number of workers in the high skill category, or somehow the amount of skill accumulated by workers, but perhaps a small amount of very high skilled workers is equivalent to a large amount of moderately skilled workers?
It depends on how we're applying it at the moment.
Okay.
For now, let's kind of think of as numbers. Later, we'll come back and say, well, if it ain't all about numbers, what else might it be? And I think that's actually an important consideration, but we're not quite ready to do that. But for now, let's think about it as numbers, and I'll come back and say numbers ain't the right way to think about it, and it's going to have some important implications. So this is the three types of growth. Then I want to look at WH over WL. That is the wage of high skilled relative to the wage of low skilled. Well, because technology is biased toward high skill, that tends to raise it. Since K is complements of high skill, substitute for low skill, that tends to raise it. However, the one response that tends to push it in the opposite direction is LH over LL. Okay? So one way to think about what's been going on over the long-term growth prospects is we've had better technology, which has induced capital deepening and induced human capital deepening. Now, when you think about that in terms of growth, these just reinforce this, right? We get a new technology. In response to that new technology, neoclassical growth model says you're going to add more capital. That raises output per worker even more. This new augmentation says not only are you going to add more physical capital per worker, you're going to add more human capital per worker, a second kind of capital deepening, further increases output. So you have the technology that raised output, physical capital responds, that further raises output per worker. Then human capital responds, further raises. All these things are accumulating together to help us grow. On relative wages of high and low skill, the first two are both raising the wage of high skill relative to low skill, but this is actually operating in the opposite direction. As we invest more in high skill relative to low skill, for the usual supply and demand reasons, that's going to be pushing the return to human capital back down. So one way to think about inequality within workers, which I think is really the place you want to think about, is it's about a race between these two forces that are pushing up wages of high-skilled workers relative to low-skilled, and the supply response, which is pushing them down. And there's two sides to the supply response. There's more high-skilled workers, that helps push down the relative wage, but there's also fewer low-skilled workers, which tends to push up the wage of low-skilled workers. Okay? So, one way to think about it is if this force, all this 1 and 2, 1, 2, and 3, if 1 plus 2 is less than 3, WH over WL goes down. Actually, though we got rising demand for high-skilled workers, supply is growing fast enough, relative wages of high-skilled would end up going down. 1 plus 2 greater than 3, WH over WL is going to go. That's kind of the way I look at it. So it's kind of a race between the supply responding fast enough to keep the return to high-skilled workers down to its old level. Very much like the capital response in neoclassical growth. Although here we don't really have that same balanced growth path type result that's going to tell us that maybe this should stay constant for. And a model like this actually can go very far to understanding the facts that we see, for example, in the United States. If you follow the United States over time, what will happen is we'll go through a period where these two forces will roughly imbalance, returns to human capital work rising very much. Once we get beyond 1980 or so, supply appears to start growing much more slowly than demand. That is, this third force falls behind these two, relative wages start going up.
So one thing about, I don't know, like segregating between price and quantity is like, for this, like, it kind of says that all workers are accumulating human,
No, not necessarily. I can divide them into different groups. Right?
Yes, so I was thinking the U.S., like, it doesn't seem like a very high, like, the intensity of, like, high-skilled workers, like, seem to pursue, like, human capital is really high, but, like, it doesn't seem like you're adding to the stock of high school, like, the number of college graduates is stable and stuff like this.
Well, what do you mean?
Well, like, basically, the people who have college degrees seem to be investing more in human capital, but, like, the number of people with college degrees.
Let me divide it into the two statements. I don't know how much time we have left, so we'll finish this up next time.
Sorry.
But no, it's fine. So here's the way I like to think about it. There's two dimensions on which, and this gets back to the question that was asked earlier. You can think about LH equals NH times HH, right? Times TH, right? Which is the amount of highly skilled human capital we have, is how many people go in that category, times how much human capital they have, times how much time they spend working, right? Because that's like the total supply of human capital in the population. LL equals NL times HL times TL. Exact same concept applied to the low skill group. Okay? So let's think about the supply response. So LH over LL equals NH over NL times HH over HL times TH over TH. Right? So that's the relative quantity. So now, let's say we go through a period, like the recent period, where this number grows slowly. So NH over NL grows, but not fast enough to keep the wage of high skilled from rising relative to the wage of low skilled. What's tended to happen? Well, those high skilled workers see higher returns. Their wages are up. Low skilled workers see lower returns. High skilled workers invest even more in themselves. Low skilled workers invest less in themselves because they're not getting as big a return. High skilled workers work hard. Low skilled workers work less hard. So what happens? The inequality. Well, that like exacerbates inequality because these guys now have not only, and it's a consequence of the slow supply growth, right? Once the extensive margin slows down and you don't have enough response on the extensive margin, these intensive margins, that is per capita margins, start responding. And they're going to respond and increase inequality even more. Right? Because, right, if you look at per person, well then this cancels out. Per person, it's all about these terms. And that's kind of what's been going on, is that not only do we have like slow growth in the relative numbers, but that slow growth in numbers has meant the returns to the two groups have should diverge. As the returns diverge, the endogenous responses, again, supply responses in the usual direction, have actually exacerbated rather than lowered inequality. Right? So the slow growth on the supply side in terms of numbers actually has fed back into the system in terms of producing even more inequality.
How to understand the flow of the supply, which
Okay, what's the blame?
and the why?
Well, there are a couple of things to blame. One is the baby boom. One is the baby boom was a big source of growth in supply. It happened for a while. In other words, we had very rapid growth in the supply of high-skilled workers like in the 70s. We had lots of young people coming into the marketplace. The other is, if you look at what's happened is, as it returns to, say, going to college or prison, more people have tried to go to college, but particularly among men, the success rate hasn't been very great. Which I think is indicative that there's a poor preparation for lots of people to go to college.
So they try not to.
Right. That seems to be, I think, the strongest evidence for people trying to fail that direction. Women have been much more successful. Women have